How do we go about solving an exponential inequality? Well, just like solving an exponential equation, when we solve an exponential inequality, we are taking a log on both sides. Now, sometimes we don't need to write the log explicitly. Like in this example, we notice that 1/9 is 3 to the negative 2. So this inequality says 3 to the x is less than 3 to the negative 2. And we can jump directly from there to say that x is less than negative 2. Now, when we were thinking about the equations, we could just say, well, this is 1 to 1, whatever. When we're thinking about inequalities, however, we need to actually think about what we're doing at this step. What we're actually doing at this step is taking the log base 3 of both sides. 3 is greater than 1, so the log base 3 is an increasing function. So we keep the inequality sign the same. If we had a number less than 1, if our base was less than 1, then we would have had to reverse the inequality. So it's important to be conscious of what step we're taking, even if we don't explicitly write the log. On the other hand, sometimes we do explicitly write the log, as in this equation. So here we have 1500 times 0.87 to the x is greater than 750. We want to say, well, first we need to isolate the exponential, so we're going to divide both sides by 1500. We'll get 0.87 to the x is greater than, we're dividing by something positive, so that doesn't reverse anything, 750 over 1500 equals 0.5. And I'm going to put that as a decimal because I've got another decimal in my equation, which suggests that decimals are nice. And 0.5 is a nice decimal. If that fraction had given me an unpleasant decimal, I might have left it as a fraction. And now I want to say x and log base 0.87, 0.5. And what inequality sign do I need? Well, what I've just done was to take the log base 0.87 of both sides. And of course we know that 0.87 is less than 1. So that reverses the inequality. We'll have x is less than the log base 0.87 of 0.5. So, using exact numbers, x is less than the log of 0.87 over the log of 0.5. Now, we have an inequality. If we want a decimal approximation, that affects our rounding. We'll take log of 0.87 over log of 0.5, and we get 0.2009. Careful. The number we write down has to be less than the exact decimal, because otherwise our inequality will fail. So we might say x is less than 0.20. That's okay. That's less than the exact decimal. I would not want to round up in a less than inequality. I would not want to round down in a greater than inequality. I'm going to round so that if I use my inequality with the rounded number, Any solution to the rounded inequality will still be a solution to the original inequality. So be careful with rounding when you're working with inequalities. We'll see why that happens and explore that in more depth when we work with real-world problems that actually require one of these exponential inequalities.